I'm Sam Stosky. I am the project manager for Primus Locus Engineering. With me today is my team of engineers who have each been assigned their own discipline, as shown in the slides. So today we're going to go over the progress we have made in the County Road 38 reconstruction project. So County Road 38 is located in Elkhart County. The project limits are just south of the heart of Goshen, spanning from County Road 19 here on the west to State Road 15 here on the east, just past the Elkhart River. So the goal of this project is to redesign the existing roadway to design for future growth in the area, while also implementing a new visitor center to promote visitor and community engagement. Both of these designs will be done in compliance with local, state, and federal regulations, and the wastewater and environmental engineers will take these designs into consideration when planning for treatment of the area. Along with being the project manager, I've also been assigned to lead the the water resources department. As the water resources engineer, my two main scopes are to treat stormwater runoff and manage stormwater runoff. So to treat stormwater runoff, I will reduce the total phosphorus load by at least 65%. This can be done in a variety of ways, which will be explored through the three preliminary designs that I will present today. I'll also manage the stormwater runoff in an attempt to minimize the runoff volume to infiltrate 1.25 inches of precipitation depth from impervious surfaces while improving the overall water quality. Lastly, I will design a flood control system to prevent flooding from the 100-year 24-hour storm and allow that flood water to be contained instead of damaging surrounding areas. So far for this project, I started by delineating my watershed and providing sufficient calculations. So to start, I decided to make it two separate watersheds, one being starting west, moving east to the bridge, and then the other watershed being east of the bridge to the end of the project limits at State Road 15. So I found the west, and I chose to make these two separate watersheds because of the topography of the project, meaning the water that will fall in this west watershed will move east towards the river, and the water that falls in this east watershed will move west towards the Elkhart River. After completing the calculations, I found the watershed of the west to be about 17.2 acres and the watershed of the east to be about 3.4 acres. Next, I got the soil survey for the project limits, which gave me things like the runoff coefficient, curve numbers, etc. And using these values, along with the watershed calculations, I was able to determine water quality volumes and flood control values. For the west watershed, I found a water quality volume of about 44,000 cubic feet, and for the east watershed, I found a water quality volume of about 9,000 cubic feet. Using the SCS method, I found a flood control volume of about 186,000 cubic feet for the west, and about 47,000 cubic feet for the east watershed. These values will be used in determining the exact dimensions for the final alternative selected and all of the designs within it. However, are subject to change due to the fact that the size of sidewalk, roadway, or building coverage could change in the future. However, today I have brought three preliminary alternatives that we will go over. So alternative one, starting west moving east, I decided to go with bioswales on the north and south end of the road. The bioswales will be pre-treatment as it moves east, eventually going through culverts, continuing through bioswales, and meeting at a third and final culvert where the north end will connect to the south end. This water will then be concentrated into further treatment of a rain garden. This rain garden will have an underdrain, allowing the water to go into a detention basin that will have an overflow where to prevent flooding of that and allow that flood to go into the river instead of the neighboring houses. Moving along to the visitor center, I have decided to go with a storm sewer system. Here I have put in grass strips to allow pre-treatment for the water that will hit the parking lot. When it is pre-treated, it will flow into the storm sewer system and exit into an infiltration basin. This basin will have a specific type of media that I will have to do further research on to allow further treatment as it infiltrates into the ground. Finally, moving to the east side of the bridge, I've gone with a curb and gutter system to allow the water to catch into the curb and gutters and catch basins and flow out to a hydrodynamic separator. So the purpose of the hydrodynamic separator will to remove the pollutants and sediments from the water and allow it to be pre-treated as it goes into the rain gardens and eventually treated to flow into the river. Moving on to alternative 2, I went with a very similar treatment here along the road with biospills, again continuing through the culverts to a third culvert into a rain garden. However, this time it will go into an infiltration basin instead of the detention basin, and this basin will have an emergency overflow outlet into the river. Moving to the visitor center, instead of the storm sewer design, I went with a rain garden and under drain. But again, there will be grass strips to allow pre-treatment before that rain garden. The rain garden will then collect the water, and the under drain will take it to the detention basin that will also have the emergency overflow exit. In this alternative, I also added 2 extra rain gardens here at the end of the parking lots to give extra treatment for runoff that will flow into that basin. Finally, again, moving to the east side, I went with the curb and gutter system, allowing the water to do the same process, and instead of meeting at a hydrodynamic separator, it will meet at rain gardens that will be supported through barrier walls to ensure they stay structurally intact and filter through to an underground infiltration storage. This storage will hold the water as it has a specific media that will infiltrate into the ground as treated water, and will also have an emergency overflow exit in the event of the large storm event. Finally, with alternative 3, I decided to go with a more cost-effective alternative. I have changed the bioswales to roadside ditches, and those roadside ditches will collect the water, again pass it through the culverts, and this time the only pre-treatment for this will be the bioswales east of the visitor center, meeting at third culvert going into the rain garden, and then again, just like alternative 2, into the infiltration basin. Going to the visitor center, I decided to remove a grass strip at the north end of the parking lot and allow any of the water that hits that north end to just go into the roadside ditch and be treated as it moves east. The water that hits the southeast end of the parking lot will go through, just like alternative 1, pre-treatment of a grass strip going into the storm sewer system and out into a detention basin. Similar to alternative 2, I decided to add the extra treatments of the rain gardens at the end of the parking lot to allow the runoff that goes there to be treated. Moving to the east side of the bridge, I went with the same as alternative 2, keeping the curb and gutter system, supported rain gardens, and the underground infiltration storage. So my plans for the future are to create 1 to 2 more possible alternatives to broaden the possibilities for this project, while also correcting the 3 that I presented today if errors come up. After having the full in-depth alternatives, I will do a cost, efficiency, and aesthetics analysis, keeping in mind that I want to be a little bit more aesthetic around the visitor center. After having a full rank system, I will be able to determine the final alternative and coordinate with my team appropriately. Thanks for listening. I will now pass the mic to Simeon.
Thank you, Sam. I'm Simeon Ayen, and I'm the environmental engineering. I'm with the environmental engineering team for PLE. So the environmental scope includes clean water treatment. This means sufficient water quality for drinking water, potable water, and fire protection water. All these must meet the most recent EPA standards. The project demand is forecasted for the next 25 years, and the daily average water use was determined to be 1 million gallons per day. The design will include efficient water source usage, an efficient treatment method, and an efficient water distribution. Additionally, no wastewater treatment is included in the scope. So the work results to date include a sized peak demand. The graph on the right was used to size the peak hourly flow rate, which was 5.3 million gallons per day, and the peak daily flow rate, which is 2.9 million gallons per day. Today, the alternatives presented will be centered around the water sources. There are more specific alternatives that exist, such as the type of treatment methods used in the treatment train, the water storage technique, and the water distribution techniques. Those won't be discussed in entirety today due to time constraints. So our first alternative consists of surface water as the water source. The project is located in the St. Joseph watershed basin or boundary, and the Elkhart River, as we know, runs on the east side of the site from south to north. So that would be the water source. The Indiana Department of Environmental Management's River Wash contains stream testing from the Elkhart River, and after examining 4 sources, 2 being upstream and 2 being downstream, some of the common contaminants or qualities of concern include E. coli, turbidity, nitrogen compounds, and phosphorus. This table on the right is an example of a station from 2021 collected with some water quality characteristics. So the next alternative includes using groundwater as the source. The project is located in the Devonian and Mississippian bedrock aquifer system, which is shown on the top right figure. Basically a bedrock system, or bedrock aquifer is the deeper layer which is confined, thus making it a very safe and good water source, but it is extremely limited in its use, at least this specific one is. So we will have to use the unconsolidated aquifer system, which for the project location is the Napanee aquifer system, which is shown in this bottom right figure in gold. The contaminants of concern, which were found using the Department of Natural Resources groundwater monitoring wells, were once again the nitrogen compounds, but then hardness, and then some heavy metals such as arsenic and barium. Arsenic being a big concern because it's a known carcinogen. So these 2 alternatives displayed side by side. The left is the surface water treatment and the right is the groundwater treatment. They both follow somewhat similar treatment trains. The groundwater is more aimed towards reducing the hardness of the water, called softening. So the order and the parts are a little different between the 2. The exact sizing of the components, as well as the exact location, is still to be determined, but close coordination with Sam and the Water Resources team will be necessary to make sure that any impermeable surface is treated for its runoff and phosphorus runoff. And then the final alternative consists of using the existing Elkhart water distribution system. The figure displays the existing network all the way on the east side, obtained from the County Road 38 survey. There's likely additional connection points up north of the site. The possible concerns with using the existing water main would be the connection points, being how feasible they are, the ample water supply, and then the routing of the pipe, whether it's enough or not. So future plans include evaluating the more specific alternatives, such as the treatment components and water distribution methods, like the piping, and the cost estimate will be done for each method to ensure that the most efficient alternative is solidified. Thank you. Here's Mateo.
Thank you, Sim. So my name is Mateo Duran. I am with the Structural Engineering Department at PLE. So here's the scope that the Structural Department was given for this County Road 38 project. So we're going to have a complete building design. And first and foremost, that will be a building that provides shelter to provide safety for all of its occupants from the both vertical and longitudinal or lateral loadings. Next, we want a building that is sustainable, one that will have a minimal impact on the environment. That could be something like going for a LEED's environmental certification. Next, we want a building that will provide entertainment, that will push guests to come and visit the visitor center. We can have places like a museum or a restaurant, or maybe even a gift shop for people to buy little knickknacks. And lastly, we want the structure to be cost effective. We don't want it to take too much money out of the county's wallet, and we don't want to up the tax money for the taxpayer. So to date, what I've done is first and foremost the structural building dimensions, getting the general outline of what the outside of the building is going to be like. And then with that general outline, I've gone and figured out the building layout, figuring out what all the different occupations are going to be inside of that building. And with those occupations, I went into ASCE 716, found the general loadings, and then was able to begin estimating what members I would need for each of those occupational loadings. And with that, I was able to come up with the 3 alternatives for the proposed general layout. So here's the general construction. Right now, this is the second alternative with masonry walls, steel beams, and wooden roof joists up here. So what we have is a 41,800 square foot building altogether, with 32,800 square feet of it being on the first floor, 9,000 square feet being on the second floor, and then 3,450 square feet of covered space, as you can see. And this is kind of just a general framing for all of the different alternatives. We can see that we have steel columns here, steel beams going across, and then roof joists that are made out of timber. And in general, we have a 40 by 40 bay going through the entire building. And this is the layout that we get with the general construction. So on the first level, you walk into a nice open lobby that will greet its customers and have people excited to be in that building. From there, you have a museum that you can go to with either maybe the history of Elkhart or the history of maybe native tribes that were in the area. You could also go to a gift shop and buy little knickknacks for your kids if you want. And to be more useful, we also have a space for Elkhart County maintenance, for grounds crew or any landscapers, so they have a base to operate out of. And on the second level, this is where the building really begins to shine, where we have our restaurant. Outside of that restaurant, you go to a patio where part of it is covered, and then from there you come to a green roof where maybe we can have native grasses planted to help us get that sustainable factor into our building. And then over here we will have a garden, which could possibly have native crops that are planted, just to be more educational and informational for the public. So, alternative 1 will be a fully framed steel structure. On the first and second floor, you'll see why I say that in the next alternatives. We will have tapered steel columns, steel beams that will be supported by those columns, which will then support the roof and the second floor. And then we'll have steel paneling all the way around the exterior, which we would like to be insulated to help with cooling during the summer and heating during the winter. And in general, this is what it's going to look like. Here's that 80-foot span that's cut in half with this W14 by 42 column, leaving us with a 40-foot unbraced length. And for these roof beams, as of now, it's been estimated that these are a W21 by 142 based on the unbraced length and the length to depth ratio. And here you can see our tapered columns, which will be estimated later at a 30-foot height for this building. So this is our second alternative, which will include masonry walls, steel beams, and timber roof joists. So on the first floor, we will have the masonry walls, which will then support the steel beams going across. And we will keep the steel columns that we have in the first alternative for that unbraced length. And then on top of those beams, we plan to do composite decking, which will create a nice concrete floor for the second floor. Then moving on to the second floor, once again, we will have masonry walls all the way around with the timber roof joist for that aesthetic in the restaurant, and then steel panel roofing on top of those timber roof joists. So here's what the first floor will look like in general with this 10-inch with masonry walls. Once again, the same beams going across and the same columns supporting. Alternative 3 is very similar to alternative 2, except with the inclusion of steel joists instead of the timber joists. So once again, masonry walls, but now we will have steel joists to support the second floor. With those steel joists, we will still have the same steel columns and the same composite decking. And once more, we have the same second floor layout as well. Here's what that first floor will look like in general. We've designated a W32 LH15 long span joist with a depth of 32 inches. And what you can't really see is along this axis here, we will have joist girders to be able to support those joists. So for the future, we look into all of the building alternatives, deciding which would be the most cost-effective, which will provide the most aesthetics, and which will be the most able to help bring safety for our occupants. After deciding which alternative to use, I'll go more in depth with the building calculations and figuring out what all the loading will be, as well as what all I need to do for the structure to support that loading. And after that, I'll go in depth with the cost estimates and really figure out how much this thing is going to cost. Thank you, and now I'm going to hand it over to Vance.
Thank you, Ted. Thank you, Ted. I'm Vance with the Transportation Engineering Department for PLE. And this is my scope for the project. So my current scope is to analyze the current traffic data and also future traffic data because it's likely going to grow in the future at some point. We also need to account for new traffic created with the visitor center. And we also need to establish pedestrian modes of transportation. The county that we are working with looks to move towards non-motorized uses of transportation. So we look to find areas for that to be implemented. And we also plan to establish driveway and parking requirements for our new visitor center. These are my work results to date. So far, I have began a traffic impact study, which basically just analyzes how traffic will be impacted by a new building in an area. And I've already did that with the addition of the visitor center. I've also began calculations so far for the peak hour and growth rate. And I've also determined the number of parking spaces that we will use in our visitor center parking lot. And I've also chosen which alternative we will utilize for the intersection. The first alternative consists of a roundabout intersection. It is a roundabout intersection with 4 separate approaches, 2 from the north and south, and then 2 from the east and west. There are 2 lanes on the eastbound County Road 38 exiting the roundabout because Vistro decided that 2 lanes would probably be necessary with the amount of through traffic flowing through this roundabout. This roundabout is slightly more controlled to guide vehicle movements. However, it allows for uninterrupted flow because you can just stop once and pretty much just go through without having to stop again. And it also would account for additional traffic created by the visitor center because it would allow for all that uninterrupted flow and allow numerous cars to get through at once. However, the roundabout is most costly by far because it has probably the need for the most land in this area, so it would probably be the most expensive in that aspect. This is just a zoomed in visual. As you can see, the highest through movement is the eastbound one going 431 vehicles in the peak hour. The second alternative consists of a signalized intersection with the pedestrian crossing. This is a signalized intersection with 4 separate approaches shown in the figure. There's a north and southbound approach on County Road 21. And there's also allocated turn movement lanes, which also will make this very ideal for a new center going into place. This is the most controlled form of intersection, and it also would account for the additional cars created by the visitor center. And it would also be safer for pedestrians because we would likely have a multi-use path in the south end of the site, and people can cross on that south end to get over to the visitor center. This is a zoomed in visual of the second alternative. And for our third alternative, it's just to keep the current intersection as it is, which is just a signalized intersection with 0 pedestrian crossing. This would be the most cost-effective option by far because you would have to change practically nothing. You just have to add your visitor center. There would be turn and through lanes in each direction. And there would also be 0 pedestrian access for the visitor center, making this the least safe option for pedestrians, especially with the county's move towards non-motorized forms of transportation. And this is just a zoomed in visual of this alternative. Parking for the visitor center will likely consist of 1 parking space per 250 square feet. We have an area for the center. From this, we found that 131 spaces will be required in the visitor center. We will have 133 spaces, with each being 11 feet wide and 20 feet long. 2 of these spaces will be van accessible, with 5 being handicapped. This is based on ADA standards from that table. And to the bottom of that, we have like general like space per square foot of like offices, restaurants, and veterinary clinics. And that kind of just gives you a visual of like why we chose the 250 square feet. And to the right, we have kind of a visual of the parking for our visitor center. So this is just zoomed in. This is all preliminary. We will likely change a lot of this in the future, especially by coordinating with other members in my group. But so far we have truck parking on the north end, and then a green area kind of in the middle, and trash on the south end of the visitor center site, with 2 entrances and exits on the County Road 21 and County Road 38. My future plans are to complete the traffic impact analysis. I also plan to finish remaining calculations for level of service. I also plan to determine specifications for a multi-use path, and also establish driver requirements for the visitor center entrances and exits. Thank you for your time. Do you have any questions?
So I have a couple questions that are pretty general, so to give some insight. So you have the hydro treatment kind of facility that you have for the water side.
Yeah.
Can you talk a little bit about, like, the scale of that on the, so when you're bringing your water in, I think it's on the water
Yeah.
resources.
Oh,
side.
yours, my bad, sorry.
Yeah, so you have the system going into, I didn't know if the whole it was like hydro or something.
Oh, the hydrodynamic separator?
Yeah.
Yeah.
So what scale is that? Like, what does one of those look like as far as like putting one in? Is it a small footprint or is it a?
So, there's enough space here. Basically, when I was doing my research on it, I did see like different sizes for it. So, depending on, you know, the amount of water that will have to be intaked in there, I can determine that. But it'll just take in that water in like a cyclonic motion, and it will like remove the sediment and pollutants, and allow the other water to then go through as pre-treatment to the rain gardens. But the size determination will be based off the amount of water it'll have to take in.
Right. I mean, would that be like an above-ground building, like with the pipes and things, or would it be something that
no,
would be below ground? Or?
It'll be below ground.
And then probably the other question is more related to environmental, but also water resources. In that, the middle or that kind of area where all that is being collected.
Right here?
Yeah, so that area on that right side is pretty, is a natural area. I mean, it's the river
Yeah.
and it's like a lot of things. So you're kind of bringing everything into kind of the natural area. And is that, I guess, I'm not familiar, is that common practice to collect it there? Or would it be
So-
better to collect it away from the natural area?
I originally had my basin moved to here, but I ended up noticing that it's too much like a marsh territory that you think about putting the basin there, and the water table is probably just right at where it's at. So I moved it up here, and I decided to have the overflow go that way, because this, in the event of an overflow, I would like to hold the water here, but in the event of an overflow, the treated water, it would be better for me to send it to this marshy area and then into the river, instead of having it overflow maybe down to here to this guy's farm, or up around here to the road and the neighboring places. Does that answer the question?
I think so. I mean, I guess it depends a little bit on what the county protects, or what
Yeah.
they view about kind of like their natural areas, if it's more protected or not than that. And I guess my last question, again, very general, for the environmental side. The two sources are surface water and the aquifer. And I know that in like Illinois especially, they have a lot of concerns about the aquifers drying up, like within the next 10 or 15 years. Is that a concern in this area?
Absolutely, especially with the Devonian, Mississippian bedrock aquifer, the deep one. It has, the DNR only allows 15 gallons per minute of use, which is very, very small. That's why it wasn't even considered an option. But even with the unconsolidated upper ones, there would definitely be some concern with extracting as much water as we're going to. So that's definitely a concern that I would have to add to that list of already water quality concerns. I don't know exactly what their limits are for water extraction on the upper aquifer, but I know there's likely city or at least county restrictions for that.
All right, thank you.
That's for
As
sure.
long as you're holding the microphone, could you go to that slide that talks about the peak hourly and peak daily numbers that you calculated?
Absolutely.
Would you explain to me what the peak hourly and peak daily numbers mean?
Of course. So those are used for designing the treatment components. The sizing of them often isn't just dependent on the average daily flow rate, which we determined earlier to be the 1 million gallons per day. The component sizing often needs the peak hourly and peak daily flow rates. So there's this chart right here which has the average daily flow rate on the x-axis. So using that 1 million gallons per day, which falls into 7,000 cubic meters per day, the graph provides with the peak hourly and peak daily. So those are just used for the design of the component, for the treatment components. Does that answer your question?
I'm a little bit confused on how an peak hourly rate is measured in million gallons per day.
Yeah. So if the flow rate was measured at heavy usage time, like 8 p.m. when people are home, if that were to be sustained for the whole day, then it would be closer to the 5.3 million gallons.
Now I get it, thank you.
Of course. Dr. Weiss?
So I have a question for Sam. So, first of all, thank you for going first. For some reason, students always seem to put the water resources at the end. And from someone with a last name that begins with a W, thank you for allowing me to go first at least once in my life, if only indirectly. But could you tell, in some of your alternatives, you had the bioswales and a drainage ditch. So can you explain what the difference is? Because that kind of sounds the same.
Yeah, so the roadside ditch here and the bioswale. So the roadside ditch, well, I guess I'll start with the bioswale. It's basically what you would imagine with the roadside ditch, but in here it would be like a vegetative swale that would be like, I would research specific vegetative like plants to put in here that would help pre-treat for the phosphorus that I need to reduce or the water quality. In the roadside ditch, I was researching would be cheaper per linear foot than a bioswale, and it would kind of just bring the water to it. I'm not necessarily going to count that as a pre-treatment for the area treating for the phosphorus, but the bioswale will be counted towards treating that amount.
So is the difference just the plants and vegetation there, or is it the shape of the cross section, or like what's the difference?
Mainly the vegetate, like the plants and things that consist of it. I haven't looked into the dimensions quite yet because I wanted to, solidify more of the calculations that I have to do, like the water quality volume and flood control volume I talked about. Those were calculated without including right now like this exact size of sidewalk or exact size of building dimensions and things like that. So they will change, and I didn't want to get exact dimensions quite yet.
Okay. And so the roadside ditch, I think you can still count as pre-treatment.
Okay.
It just won't be as much as a bioswale, but if you do it right,
Okay.
still. And then the infiltration basin, there, like you said, you moved it kind of to higher ground.
Yes.
But do you know, like, where the water table is there, and do you know the depth of, and like what the regulations are for any clearance between the water table and the bottom of the basin?
So, well, to start, I did move it there because there is an existing pond there.
Yeah.
So I thought, that would be a lot better than this area here. But to answer your question with the regulations with the water table and a certain depth, I do not have that answered yet. But narrowing down and finishing these alternatives to be exact, and then adding the one, as I said, in my future plans, I do plan to get all those regulations solidified and exact dimensions.
Do you need to make the existing pond deeper, do you know, or you haven't gotten there yet?
I don't, I probably will make the existing pond deeper due to planning for more runoff, because this will not be impervious, and in this alternative specifically, from here, this water will run into and come east, but
Is one of your alternatives at the building permeable pavement?
I do not have permeable pavement. But
That,
I do plan to have one or two more alternatives, and permeable pavement was one of the things that I was gonna look into. I just didn't know how much I
yeah,
liked
I mean, that could reduce the size of your basin, right?
it. Yeah,
So,
yeah.
okay.
Since you're holding the microphone,
Yeah.
I don't know how long the project is. So, and maybe you haven't yet calculated, but somewhere along the way you said you're gonna take water from the north side of the road through a culvert to the
Yes.
south side of the road.
So spanning from here to about the bridge is about somewhere in the range of 8,500 to 9,000 feet, if I remember that correctly. And these will pass through the culvert, continue through the biosphère and pass through the culverts here, and then continue down. And I wanted to run this water and just concentrate it all, since it was pre-treated together. And instead of running it into the river, because there is regulations about the flow rate going into the river, so it needs to be like slowed down and things like that. So the culvert here will bring it from the north end to the south end.
Okay. Again, you need to calculate the numbers and all that, but
Yes.
my concern is that culvert might be pretty big.
Yeah.
And then, you need to make sure you have room under the roadway and above the outlet. That, you may need more than one, is what I'm saying, or two.
Yeah. I have not.
If you have if it ends up the volume of water requires a 4-foot diameter pipe, well, do you have enough gradient to get that where you need to go? So,
That's a good point, and I have to look more into the size of that culvert to see if it would even be an efficient alternative. So that will be something to do for all three of these alternatives, to narrow down any errors I've made and make sure the final alternative will be sufficient.
I saw, yeah,
Yeah, go ahead.
I saw a green roof somewhere on a structural slide.
Yeah.
So is somebody gonna design the green roof? And would that be the water resources person or the structural person, or?
So we're going to coordinate that later on as to what the infiltration rate will be for that. But I will go ahead and design that just so I can get the occupational, or get the loading for the, whatever members are going to be supporting that. And then from that, Sam will take that infiltration rate into account.
Thanks.
Any other questions? All right, thank you, everybody.